So, hello everyone, welcome to Docker Part 3. Before Docker Part 3, I have taken Docker Part 1 and Part 2. So, you can always subscribe to Sayam Pathak's channel and view my previous recordings. And yes, I will be giving you a quick recap also what I covered in Part 1 and Part 2. So, you can go back and see. And if you already know about that, then it's good to start today. So in part one, I have described why Docker is required and what is the difference between VM and Docker. And we have run or gone through few simple commands like how to create an image and how to run a container. Few commands like that. In Docker part 2, we quickly ran through few another commands and created our own Docker file. And then I explained about container lifecycle, like how does it work, when it stops, when it runs, and how you can make your own container running for a longer time. And yes, now today I will be covering Docker part 3, that is Docker storage. So we will be quickly going through how many types of storages, how you can create your own volume, what is block-based storage, what is object-based storage, how you can create your own volume, and we will be using Katacoda as a playground. Um, you can use any of the playgrounds, play with Docker also, uh, with the ones you are comfortable. So I will be using Katacoda Ubuntu playground. So, moving on to Docker storage, why I want to cover this part is because Docker storage is really important when it comes to the containers. So, as you all know, in the previous part also I have explained that contain in the container lifecycle that containers are ephemeral in nature. So what happens is we just start a container, and when the task is over, it just exits out and it just move away. It just complete its task and go away. So you must be thinking that where the data is stored when how to store the data when you stop your container or when the container is exited. So this is what I will be talking about today. So when we start a container, in that container, you just imagine you are running a mission critical application, and it could be a DB or a number of containers with tier 3, like a database. Then you have a middleware and a front end. So let us suppose we are running these three containers, and each of the container will be needing its own separate data which it needs to access in order to do their jobs. But you must be thinking where this application data will be stored. And um, and yes, it shouldn't be stored in the containers. As I mentioned before, container is ephemeral in nature, so it containers are stopped, so data is not accessible at all. And containers are stored on each host, and the container file system wasn't designed for high performance input output. So these are the few features why you should not store your data and why the data will not be stored on the containers. So this is the reason. So now moving on to the next slide, what are the options available? We'll be going through these three options, and we will be creating our own volume as well. So let's imagine we start off with a container, and on the container is running on top of some file system, and Docker has the access to the specific area in that file system. So this is how the Docker volume runs, and this is how the Docker volume performs. So this is the recommended way to store your persistent data. And if you'll go to your uh, uh, this server and check in var lib Docker volumes, you can just find that. Now, moving on to bind mounts, it has limited functionality, and you must use the exact file path on the host. So we will be don't worry about that. We will be quickly going to Docker docs and in the Docker in the playground, and I will be showing you all this. So if you're not getting right now, don't worry about that. So just a little bit of theory. So bind mount directly have the access to the FS, whereas the Docker volume stores its data inside the designated area in the FS. Now coming on to the TMPFS mount. So how it is, it stores its data inside the memory on the host where the container is running. So basically, this TMPFS stores your temp FS stores your data in the memory of the host where your container is running, and it is least recommended. So it's not that much used, and because it's not good to store your memory or in the memory, so it is the least recommended, and the Docker volume is highly recommended. So this is the path, and these are the storage options available when it comes to Docker storage. So as I explained earlier, this diagram is taken from docs.docker.com. So from there, this look for me, it looks very easy to understand from this diagram how bind volume, Docker volume, and temp FS mount works. So I will quickly go through again so that you will be clear in this. So again, I will tell you that how the Docker volume is working. So Docker volume have a specific area in the file system. So where it stores your data. So Docker volume have specific area. Now coming to bind mount. Bind mount has direct access to the area. Okay, whereas the Docker volume is storing the data directly in the designated Docker area. And now, whereas coming to temp FS mount, what is happening here is it is directly storing into the memory where your container is running. So it is very important when you are storing your data, you must know these three options, and you must plan where you want to store your memory, your data before starting your project or before starting your critical applications. Obviously you must be knowing where you need to store your data. And yes, as I mentioned, Docker volume is highly recommended over here. So now moving on to this part, block versus object storage. So we must be knowing this part as well. So what is block? Block is fixed chunks of data in this no metadata is stored, and best for input output intensive applications. And SAN storage uses block storage protocols like ISCI, SKC. And object, when object storage is used, so data is stored with metadata and unique identifier. How it works here is, and there is no organization to the object. Scalability is limitless and accessed with HTTP calls. So Amazon is example of object based storage. So here is a short diagram, very small diagram I have placed over here. So this is the example of object based. So block based storage is typically used to store persistent application data, whereas the object storage is used to store Docker images data. For example, Docker container registry, if we'll see, and this is the example for that. Now moving on to the next slide. So Docker container uses a layered storage file system, and this is the representation of this. So as you can see in this diagram, that in this PPT, the Docker image contain multiple read-only layers, and multiple containers are typically based on the same image. So when an image is instantiated into a container, a top writable layer is created, which is deleted when container is removed. So as you can see, we have a manifest over here, and then it tells, manifest is nothing but a text file or commands which tell you what to do. And then suppose it tells us to do install operating system, and then we need to perform some configuration changes, and then over on top of that we need to place our application, and then we need to do some more changes. So this is the Docker image union file system, and this is container layers, which I will be showing you in a while when we'll move on to Katagoda. So it creates a writable layer over it where you can make changes. So which is always deleted when the container is removed. So now what we'll do is we'll move on to the Katagoda, and we will see how to check this out. Okay, so we are in here. So what we are going to do is first we will be checking Docker images. What all images are present over here? Another command, Docker image ls. So these are the images right now available on this host: Ubuntu, Redis, Alpine, and all. So quickly we'll be clearing our screen, and what we are going to do is now we will be pulling a web service. So Docker pull. So let's do this right away. You can always run along with me, and if you have some issues or some questions, paste onto the YouTube channel chat section, and there is Sangam and Sayam is available to help you out. So this is what we have done now. We have pulled HTTPD image. Now quickly let's check, do we have our image in there? So yes, it's here, CCBC, and let's clear our screen again. Now what we are going to do is we will inspect this image. No need to type full name, and you can just go ahead with this. Okay, let's clear out screen. Moving on again. Okay, so this is the image. So Docker image inspect. Okay, let me increase it. So what I have done is I have inspected the image which we have pulled just now. So why I did so, I just wanted to show you the layers over here which I was talking about in the PPT. So you can see these are the layers, and now I will be showing you how these layers are formed and where the data was stored when these commands were running. So what we are going to do is we will be quickly going to Docker history. Okay, so now as you can see, it has added a file of 2 MB, and here you can notice missing. Why it is missing? Because it has run on the other host, not on these hosts. So this apt-get and all, every commands, these commands, missing ones, ran on some other host. And now let's quickly move on to the upper half of this. Yes, so now after doing so, this image ID was created on our server. So this is how Docker storage works, and you can always use Docker inspect image and this command to see how it worked, where and all it's stored, what are the layers, and what command ran on our host, and what others or what commands are present in here, what it did basically. Okay, now let's go back to our PPT. And now what we will be, so I hope you understood this image layers. If you have any doubts, just type in your doubts into the chat. So now I will be discussing about storage drivers. So this is the link. You can always go and open it and read it out. So what I will be going, I have already opened it, and we will be going there and exploring the feature. Let's go ahead with Docker storage drivers. So I will give you a quick read. This is very important if you want to learn about the Docker, the storage part. So ideally, very little data is written to containers writable layer, and you can use Docker volumes to write the data. So this is why we will be using Docker volumes. So as I explained earlier, it contains a very thin layer, very little writable layer where you can make changes. But if you want to store more data, and if you want your data, you want to preserve your data, you should use Docker volumes to write your data. However, some workloads require you to be able to write to the containers writable layer. This is where storage drivers come in. So Docker supports several different storage drivers using a pluggable architecture. The storage driver controls how images and control containers are stored and managed on your Docker host. So if we will scroll a little bit down, and here you will be seeing Docker supports the following storage drivers. So if we see here, there is overlay 2 and is the preferred storage driver for all currently supported Linux distributions, and it requires no extra configuration. There is another AUFS, and it is preferred storage driver for Docker 18.06 and older when running on Ubuntu on kernel 3.3, which has no support for overlay 2. Now coming on device mapper is supported but requires direct hyphen LVM for production environment. We will be going through overlay and this also, while zero configuration has very poor performance. So device mapper was the recommended storage driver for CentOS and RHEL. So this is a thing. And now let's move on a little further. Here are some here is some more information about this. So please, I would recommend go through docs.docker.com and spend some time. And this is really important if you are thinking for DCA, if you want to become Docker certified. So these concepts should be very clear. So if we see here for Docker Engine Community Edition, Docker Engine Community, Linux distribution. So if you have Docker Engine Community on Ubuntu, so what is required? Overlay 2 or AUFS. And if you have Docker Engine Community on Debian, so you require overlay 2 AUFS device mapper, and Docker Engine Community on CentOS, then overlay 2, and so on. Fedora overlay 2. So this is the thing. Now we'll move on a little lower for Docker Desktop for Mac and Docker Desktop for Windows. So these are some of the supported backing file system. So I will just recommend please go through this before you are setting up something and doing so. So overlay 2 overlay uses supporting backing file systems as XFS with type 1 and AUFS. So this is the thing, and these are some of the other considerations. Now we will go to some a very important point over here. So this is really important, and yes, in double quotes I will say, when you change your storage driver, so any existing image and containers will become inaccessible. So if you are having some images in your server, and if you will change a storage driver, your existing image and containers will become inaccessible. So this is because their layers cannot be used by the new storage driver, and if you will revert your changes, you can access the old image and containers again. But any that you pulled or you created using the new driver are then again inaccessible. So this is very important point over here. So let's move on quickly to overlay fs over here, and let's just check it out what it is, and we will be doing that. So we will be working with this as also in Katagoda. So just to make you understand a little bit about overlay fs, that is the reason I'm going through this doc. So overlay fs is modern union file system that is similar to AUFS but faster with the simpler implementation. Yes, it is very simple to implement. We will just see in a while how to implement it. So Docker provides two storage drivers for overlay FS, and this is the older one, original overlay, and we have newer one that is overlay 2. And if you will go down, these are the few of the prerequisites, and this is the warning. And configure Docker with overlay or overlay. Now we will be going through the steps how we can configure Docker with storage driver overlay 2. So we will be checking with overlay 2 because Katagoda is having overlay. We will be checking just now in a while. But before that, I would like to show you the commands. So you can just visit this. Sayam Sangam, you can paste this link and so that they can go through and do that. So you first, what the first and foremost step is, you need to stop the Docker. So sudo systemctl stop Docker, and then this is highly recommend that you take a backup of your val lib Docker. So it is really important. Backup is really important to do so. And if you want to use a separate backing file system from the one used by Vanlib, format the file system and mount it. Make sure add this mount to make it permanent. Now what we will be doing is we will be editing this JSON so that you can just change your storage driver. And if you will see in your server there is nothing mentioned like storage driver, so go ahead and just add this line over there. Okay, so that your daemon JSON will start. Now after making the changes in the file, what we are going to do is we will be starting our Docker back. So let's go to Katagoda again and let's see how we can check what storage driver we have right now. So moving on to here, Docker info. So it gives very long output. What I will be doing here is I will be giving pipe and more. Okay, so let's go little here, little. So storage driver we have is overlay over here right now. So this is how you can check what type of storage driver you have currently in your server. So this is the one. Now let's move out of this and let's clear the screen. And now what we are going to do is we will be to change our storage driver, and to make the changes in the file, it is recommended. So we should stop the Docker first. Sudo systemctl stop Docker. Let's stop Docker on this server. So it is stopped. Now If you remember, the next step was to take the backup. So I'm not doing it just to save some time. So you can, but I will tell you the command: au and var lib docker. And if you want to back up the same thing with the same name, so you can just do this and give it, just give .bk here, so you can do so. Now what we are going to do is we will be making changes to our daemon file. So let's go in here, vi slash etc slash docker and daemon file. So if you will see here, I will be inserting. So if you will see here, storage driver is mentioned. So if in your server, don't get confused, if in your server nothing is mentioned, you can just add this line storage hyphen driver. So what we are going to do is we will be changing it to overlay 2 escape. Okay. And we will be saving it. So now we have saved, we have changed the storage driver. And what we are going to do is now we will start our Docker back and we will check again what storage driver we have now. Start Docker. Okay, now the Docker has started. Let's check what storage driver we have in here. So we have successfully changed our storage driver in here. So this is how you can change, but please remember the image is stored and the images which you pulled using the old storage, that is overlay or any other, if you have, it will not be present in overlay 2. So please be careful while doing so. And what I'm going to do is now we are done with this. Now what we are going to do is we will be moving on to the Docker volume section. Let's go there now. Let's move on to Docker volumes and learn more about the Docker volumes in here. So let's give a quick read over here. Volumes are preferred mechanism for persisting data generated by and used by Docker containers, while bind mounts are dependent on the directory structure of the host machines. Volumes are completely managed by Docker. Volumes have several advantages over bind mounts. So volumes are easier to backup or migrate than bind mounts. You can manage volumes using Docker CLI commands, and volumes work both on Linux, Windows containers. Volumes can be more safely shared among multiple containers. Volume drivers let you store volumes on remote host or cloud providers. New volumes have their own content pre-populated by a container. So this is the exact diagram which I have shown you earlier, and you can always go in here and read more about it. So let's go down a little down and check out what are the options. So hyphen V or hyphen volume, it consists of 3 fields separated by colon characters, and you can read more about it. And hyphen mount consists of multiple key value pairs separated by commas and each consisting of a key value. We will be seeing this in a while, so don't worry about that. And let's go on below differences. You can go in here and check out the differences for both hyphen mount and hyphen v flags. So this is how you can inspect the volume. We will be checking this also. How to start a container with a volume. So this is the command. And if you have -b, so this is how it looks. And you can just go through this. So, okay, but what is there? I want to quickly go through one point which I think I skipped it before moving to Docker volume. Let me go through device mapper. So when before going through the demo part, let's move, let's check out device mapper first. So this is also I wanted to show you. I skipped it. So device mapper is a kernel-based framework that underpins many advanced volume management technology on Linux. So this is also a device mapper. Storage driver leverages thin provisioning and snapshotting. So please go through this also once. Um, and we need to configure loop hyphen lvm mode for testing. So these are the few of the steps. So if you have overlay, try to explore it and change it to overlay 2. And if you want, you can just go through this steps and change your storage driver to device mapper. You can always go through these steps, and it tells you how to configure direct hyphen lvm mode for production as well. And these are the options description. Please go through these things and try to do. It also tells you how to configure your direct hyphen lvm mode manually, and it also states how to keep your data in production and how to run your data in production. And it also tells you about some performance best practices. So if you want maximize your performance, please use direct hyphen lvm, use fast storage, memory usage, and this is the one. So I just quickly ran through this. Please visit this site and read more about this. Now let's go back to the docker volume part. Okay, and it shows us share data among machines. So when building fault tolerant applications, you might need to configure multiple replicas of the same service to have access to these files. So I will not read through the full document. I would recommend please go and check how to backup, restore, and read this and how you can create your own volume. So let's quickly move on to the Katagoda, and let's check it out how to do so. So now what we are going to do is we will be checking if there are some volume mounted it in here. So currently we don't have any volume in Katagoda. Now what we are going to do is we will quickly mount Saloni dot wall. You can use any of the name, your name, and just we will be trying out to do so. So Docker, we will be running a container, and in detached mode, obviously in background. And then we will be mounting source. You need to specify in here. So what I'm going to do is I will be writing Saloni dot wall. So you can use your name in here. And now we will be giving target. So where it will be storing, so I will give root. So whatever you can give, or where you are comfortable in temp, or in you can create a directory slash app, anything you can store in there. But in order to save time, I'm quickly using root in here, and we are running a Docker container and mounting the mount in there. And source I'm giving a Saloni hyphen wall, and target. Now let's quickly run it. And what it is doing, it is pulling image, and it's done. Let's clear this and quickly check the containers in here. So Docker ls. Yes, this image is there. And now what we are going to do is, this container is there. Now what we are going to do is we will quickly inspect, try to inspect AAF, clear Docker container inspect. Okay, I forgot what it was, AAF. Yeah, it was AAF. And let me maximize my screen so that you can see clearly. So what we have done is, we will see here, we will go to the mount section in here and see what actions we have performed, how the, okay, so this is the mount section. What I have done is, it is type volume, and I have kept the name as Saloni-wall. You can change it. And what is the source? So this is the source, and this is the destination. I have mentioned it slash root. You can use your, and this is what it performed. And now let's clear the screen and inspect our volume. So how you can inspect your volume? So the command for doing is docker volume inspect and your volume name. So in my case, it was Saloni-wall. So here's it, and this is how you can see the details. It is created at driver, mount point, name, scope, null. So now let's quickly move on to the other bound bind mounts, and let's quickly try type bind mounts. Please go through this. I want to give some time to Sangam and Sayem also. So you try it out, and for now, please read through this. And for now, what we are going to do is, I will quickly go on to Katacoda and show you how you can use type mount type bind. So now what we are going to do is Docker. We'll be running a container run, okay, and -d mount, and type. We need to specify the type in here. So we are using type bind, and source. If you see a little bit of difference in here, what source we are mentioning here and what source we mentioned. So I'm using /tmp here. And target, what we are going to do is, we will be using root in again. So I missed the slash in here. And now, so again we will try to do so. Let's see what happens when we do so. Let's run. So this is how you can run your container using type bind. Please go through the document and explore it. And this is how it was done. So here this document is very clear and very nice. It explains all the steps, how you can do how can you can use bind. So I just don't want to read it through and waste your time. You can read it yourself. And now let's move on to but before moving on to the last slide, I want to share one thing, that is Docker uses storage drivers to manage the contents of the image layer and the writable container layer. So each storage driver handles the implementation differently, but all the drivers use stackable image layers and the copy on work COW strategy in here. So let's see the last. And let me cover one thing first, moving on to last slide. Like with volumes, if you have noticed, we didn't had to create a volume ahead of time. We simply started the container and we specified we want to mount the volume, like xvz xyz and whatever, we just gave the name and it automatically created for us that volume. But with bind mount, if you have noticed, we need to create the source or folder which will be mounted by the containers. That's using the bind mount. So let me go to the last thing over here that I wanted to show you is prune. Okay, so this is Docker prune. This is how you can clear your images, how you can perform, how you can. So this is the last part. So if you want to if you want to learn more about this prune volumes, please go through this and just give it a read. It is very good and this is required for your Docker certification as well. So Docker system prune remove unused data. Docker system info displays it. Docker system events get real-time events from the server. Docker system df show the Docker disk usage. So just give it a read. Uh, just go ahead and learn it. If you have any doubts, you can just post me on my Twitter profile, that is I underscore Saloni 92. And just now also you can just go through, you can just type in your questions. Thank you, Sayam. Over to you. Thank you all for attending it.